Okay, so in this video we're going to look at atomic number and mass notation, and specifically given numbers of protons, neutrons, and electrons, how can we write the appropriate symbol for the following ions? If you remember that atoms get notated with A, the mass number, over Z, the atomic number, okay, the identity of the element X, and then we throw the charge up in the usual place, up and to the right. Okay, so given that this is the format we need to put it in, we can start working on A. So the first thing we have is 17 protons. Well, we know that number of protons determines the element, so that is the atomic number. So 17 is equal to Z. Okay, and now looking at the neutrons, okay, we know that the mass number A is equal to the number of neutrons plus the number of protons. Which means that it is equal to 35. Okay, 17 plus 18. And then the last thing is we need to figure out what to do with these electrons. Well, we are now staring at something that has the other things done, so we know that it's 35 over 17. Okay, we can look up on the table and see that 17 is chlorine, so we actually have 35, 17 chlorine. And now for the charge, well, we have 18 electrons, so we have 18 minus, and we have 17 protons, 17 plus, so we're going to have a net of minus 1. So you write it, and this is our answer now. Okay, we have chlorine 35 with a charge of minus 1, the chloride ion. That's not what I wanted to do. Okay, for number B, we're going to do the same thing. So again, we know that Z is now 29. And we know that if we add 29 and 34 together, we get 63. Okay, if we look up number 29 on the periodic table, you can see that for Z of 29, that gives us copper. So we're dealing with copper. Now we just have to deal with the charge. The 29 and 34, again, protons and neutrons together made up our A. And now for the charge, we need to just compare. We have 29 plus charge from the protons, and we have 27 negative charges from the electrons. So if you look at it, 27 minus 29 plus, we net out to 2 plus. So that is going to be the copper 2 ion, copper 2 plus. Okay, so that's how we write the correct notation for this. Okay, for these two problems, we're going to actually work backwards from what we were doing before. And now we're going to be given the symbol and the mass number A, and we're going to have to use this to figure out number of protons, neutrons, and electrons in the actual atom as written. So in the first one, we can see it's 97 technetium. So the first thing we need to do is sort of get a little more information here. So we know that it's 97 over, we need to look on the periodic table. You look it up, it's number 43, so that's our Z, so we're really dealing with that. And we know that it's got a charge of 0, it's neutral, so we're not really going to have to worry about the charge at all there. Alright, so looking at this, we know therefore that our protons is equal to Z, so our protons are equal to 43. We know that the neutrons is going to be the difference between the protons and the mass number, so 97 minus 43. Okay, and that's going to be equal to 54. And lastly comes the electrons. Okay, in this case, because it's a neutral atom, the number of electrons, the minus charges have to balance out the positive charges from the protons. We have 43 of those, so we must have 43 electrons. So if we take a look at it here, protons 43, our neutrons are 54, and our electrons 43. Okay, let's take a look at the second one. Okay, for this one we are looking at nickel, 63 nickel 2 plus, And the first thing we need to do again is look on the table. You can see it's a transition metal. It has a Z atomic number of 28. That means that the protons are 28, right? Because that's equal to the atomic number on the table. Okay, again, finding the neutrons now. We need to do the mass number, 63. And we need to take away the number of protons, which is 28. Okay, and so what we're going to end up with is 35 neutrons. And then the last thing we need to do is the electrons. Now here's a case where we have a charge. So we have to deal with this a little differently than we've been dealing with it up to this point. And the way we need to do is take a look at the net of 2 plus, right? We've got an ion here. So we know that we have 28 plus as our charge. And therefore we know if it's going to end up as 2 plus net, it's got to be 26 minus, because that would give us 2 plus net charge. We have 2 fewer electrons than we do protons. So that means for the electrons, okay, that's simply going to be equal to 26. Alright, so there you go. 26 electrons, 35 for the neutrons, and 28 for the protons.